Step 1, design objectives. Now let's start by looking at step 1, design objectives. It has to be decided how the system is to perform. This will be decided at the design review. There are a number of possible design objectives for a smoke control system. The main four are temperature control, property protection, to assist firefighting operations, and to maintain means of escape. Let's look at the design condition for a temperature-controlled smoke control system. Now, it is essential that the temperature of the smoke is neither too high for life safety or too low so as to lose its buoyancy. Firstly, the system can be designed to ensure that the temperature of the gases in the buoyant layer is not excessive. If the smoke layer is above 200 degrees Celsius, it creates conditions which are classified as untenable for life safety. This is the temperature which causes pain to anyone having to walk beneath the smoke. Now, the heat can be vented by the smoke exhaust system to ensure that the heat flux to critical structural elements is kept below acceptable criteria. Another reason for keeping the temperature below a certain level is to enable you to specify materials with a lower than required fire resistance than the codes normally require. A typical example is where an atrium facade has glazing which is not fire resisting, but which is known to be able to survive gas temperatures up to some specified value. Another example was in an airport where the structural steel did not require the usual 2-hour fire resistance protection because it was demonstrated that the smoke temperature would not exceed 400 degrees Celsius. Usually in these systems, the inclusion of measures to limit fire size are required, and this may include sprinklers or some other fixed installations. It also has to be ensured that the smoke has sufficient buoyancy because, if not, in a natural ventilation system, there may be insufficient buoyancy to exhaust the smoke effectively. Generally, the temperature of the gases must be at least 20 degrees C above ambient temperature. If it is any lower than this, mechanical extraction should normally be specified, or CFD modelling would be required to demonstrate that the system meets the design objectives. Let's now have a look at the next objective, property protection. Where property protection is the main purpose of the design, it is necessary to specify a height of rise for the spill plume that allows the layer base to be safely above any vulnerable property or goods that are being protected by the system. For temperature control systems, the height of rise of the spill plume is chosen to achieve the desired temperature in the smoke reservoir's buoyant layer. So that's the difference. Property protection systems can also be used in large warehouses or factories to protect the contents. The next design objective is to assist in firefighting operations. In extensive and multi-storey complex buildings, firefighting and rescue operations can be severely hampered by the presence of hot smoky gases. The travel time from the fire appliance to upper and lower levels can be improved by the provision of smoke control systems installed primarily for the occupant's means of escape and for the protection of property. But smoke control systems can also be installed for firefighting alone, and here the design criteria will be different, reflecting the specialist equipment, clothing and training of the fire service personnel. Now, the primary reason for installing a smoke control system is for protecting means of escape, and this may allow freedom of design to architects and designers. This objective is to achieve a desired smoke-free clear layer beneath the smoke layer. This approach is commonly used where the purpose of the smoke and heat exhaust ventilation system is to allow the continued use of the escape routes which are in the same space as the fire. For example, this may include enclosed shopping malls and many atria or large single-storey spaces such as public assembly buildings. The thermally buoyant smoke forms a layer beneath the ceiling. The smoke extraction required is calculated to be large enough to keep the smoke at a safe height above the heads of people long enough for them to make their safe escape. It is essential that the system comes into operation as early as possible during the fire, and it is usual to initiate operation automatically on receipt of a signal from a smoke detection system. Limiting the accumulation of smoke means that the base of the smoke layer can be controlled. Early in the design stage of the building, the designer needs to decide where the base of the smoke layer can safely descend to, or how rapidly it can descend. This decision is guided by a number of parameters that have to be observed. The minimum clear layer height for various buildings for life safety is as follows. Public buildings, for example single-storey malls, exhibition halls, etc., 3 metres. Non-public buildings, for example offices, apartments, factories, open hall type prisons and such like, 2.5 metres. Car parks, 2.5 metres or 80% of the height of the space, whichever is the smaller. You should note that where the predicted layer temperature is less than 50 degrees Celsius above ambient temperature, it may be a wise idea to add half a metre to each minimum value mentioned. This is guidance that is given in some documents but not all. You should also be aware that the buoyant layer in the smoke reservoir should not be designed to be less than 1/10 of the floor to ceiling height for fires directly below the smoke reservoir, or less than 1/10 of the height from the spill edge to the ceiling for spill plumes. Let's look at some examples of design objectives. As an example, the design objective for a warehouse could be to maintain the smoke layer half a metre above the highest stored goods until the fire brigade arrive. In a warehouse with a mezzanine floor, the design objective could be to maintain a clear layer height of 2.5 metres above the heads of the occupants on that mezzanine floor. In a shopping complex, the design objectives might be to maintain a clear layer height of 3 metres above the heads of any members of the public. In an airport terminal, the design objectives may be not only for life safety, that is to maintain a 3 metre clear layer height, but also for structural purposes. For example, if you can demonstrate that the smoke will not exceed a certain temperature, say around 400 degrees Celsius, then the steelwork may not need the usual level of fire protection. So before starting to determine the smoke ventilation requirements, the design objectives have to be decided upon. It's then possible to determine the requirements of the system in order to achieve those objectives. That covers step 1. Now let's move on to step 2, determining the design fire size.